Hello, once again, and welcome to the Engineering Moments podcast. Today, I've got Baron again, second time visitor. Really happy to have you again on the show, Baron.
Thank you, Ego, for the invite.
Yeah, yeah, no doubt. So today we're going to be talking about the future of AI in software development. A really hot topic these days, especially with all the advancements that have been made in AI. Right. So I think I wonder where's a good place to start. I want to tell you some of my experience with. I don't have a ton of experience with like integrating AI and software development, but I do have some. And I think the most recent one was I did a pilot with my team to check the impact of using AI assisted tools. I think at the time we tried we tried a Tab 9 and Copilot. So we ran the pilot for I think about a month or two to try and see if there's any uptick in any metrics that we generally measure. And at the end, there wasn't any like some things went up, but there was no direct there was no, it was hard to find any direct cause because, it just depends. Sometimes you're working on a certain project and you're faster because of the domain knowledge that you already have. So there was nothing conclusive, let me put it that way. But I think the important thing is that the developers felt like it helped them. They felt like it helped them, but overall, when I compared it to how well we did in the past, I didn't see anything dramatically change. So I feel like maybe it's something that you gain the more you use it, or over a long period of time. I also spoke to some other EMs at the time who had run similar pilots with their teams, and they had similar feedback that the biggest swing was in developer satisfaction. So anyway, so just wanted to paint that picture for you and see, okay, what is your experience with sort of like AI in software development? Do you have any experience with any of these tools, and what have you learned so far?
Yeah, my experience with AI in software engineering in general has been very similar to your experimentation, but I'm not really concerned about some of the key metrics that could be used on how to identify whether these solutions are working well or not. I'm mostly interested in the impact of these adoptions on the long-term viability of the software engineering industry. So I can see how it has a very great potential to change the whole software development life cycle.
Okay.
For example, for now, for any entry level job in software engineering, we're expecting engineers to have skills in data structures, algorithm, and maybe object oriented design, and so on. In the near future, because all of these huge models, large language models, they are evolving at a very alarming rate, and their level of precision is increasing exponentially. We will assist in a phenomenon where the entry level requirement for a software engineer will change. For example, they will be required to have solid understanding of prompt engineering.
Okay.
They will be required to have solid understanding on how different machine learning and deep learning model works, like how can you implement regression, how can you implement classification, can you implement a Gen AI, and how do you understand different architectures for Gen AI, like transformers? How does it work? What are embeddings, and so on? So those will be the basic requirements of a software engineer beside the traditional skills we have. And that has implications as well on how we build software, the
Okay.
tooling itself. Right now, we have a developer, we have to write code, and then we have in IDE, and we have a compiler or an interpreter that need to take that code and translate it either in binaries or in bytecodes, depending whether we are executing them directly on the machine, or we have an intermediate layer like a JVM or CLR that will later convert it in binary. With AI gaining more momentum in the software engineering industry, that architecture will change. So we'll have this developer need to use prompt engineering to give instructions, not to the compiler in the traditional way, but to a large language model.
Okay.
And that large language model will generate code. And that code will then be executed on a compiler or on an interpreter. At the beginning, we'll have some manual intervention to try and ensure that the quality of the code manually or visually. But as we generate more knowledge in that field, with these transformers becoming more and more sophisticated, we won't even need manual intervention. So the transformer itself will generate code, will develop unit testers, and then will provide you with the result, with the correctness of the module you just developed using prompt engineering. So with that, understanding a programming language will be useless because the large language models will program better and faster than anyone else. So one of the new skills that would be critical even for entry level will be software architecture. So understanding how to build systems, how to connect components, how to measure scalability, I think that won't be a skill for senior engineers anymore. Will be something expected for someone coming in because writing codes won't be something that they need to do because the large language model using deep learning will do faster and better than them. So these are the changes I see happening in the near future in the software engineering field.
That's very, very interesting. From what I'm getting from what you're saying, it's like you think that soon engineers will be more about the architecture, looking at the big picture and how all the pieces fit together. They won't necessarily need to spend their time writing code
Exactly.
because the system will be able to produce the code obviously faster, and with time even sort of validating the code will not be necessary because it would have learned well enough to have like 5.9 level of accuracy, something like that.
Exactly. So the accuracy will improve in both layers and the
Hmm.
tooling will change. The IDE, the integrated development environment we're using right now, like Eclipse or Visual Studio, and will change as well. So the
Interesting.
user interface will be based on prompt engineering,
Hmm.
where we give instruction to the large language model using natural language and not
Hmm.
programming language.
So from your, I mean, that seems like a future that's sort of far away, but like how, I know it's sort of hard to guess, but where are we now, and how far away do you think that this future you're talking about is?
So right now we're still in the embryonic era of that
Hmm.
for two major reasons. The first reason is the models need to be trained more on a variety of programming language to reduce the lost function considerably. The lost function is a linear function that's usually used to measure how well a model in a neural network can predict or generate new content or new insight. So if we look across diverse programming language, we are not there yet to completely shift to that paradigm. And also the second issue that we have right now is the skills. Many universities still training software engineers in the traditional way, and AI still considers a specialty. So after you went through your engineering degree and then maybe at the master's level, you could choose to focus on AI. So that needs to change as well. AI should come from year one. They need to learn the basics of AI and then build on that. So because we're still in the embryonic era, but we are having a different tendency on the other side, on the architecture itself, with the advent of AI agent, for example. So that will actually be a catalyst, be the catalyst of start changing the skill set for software engineers. But because maybe in the next 5, 10 years, software engineers won't be building traditional software; they'll be building AI agent. And AI agents will require skills in machine learning to understand how machine learning works. But there is also some misconception. I heard the CEO of Microsoft claiming that because of the booming of AI agent, the software as a service model will vanish. So that's a very bold statement, but it's inaccurate because software as a service is a delivery model. How do we bring the software to the user?
Mhm. Yeah.
But AI agents are an architectural pattern. How do we build software? So they are not mutually exclusive because right now we still have many systems that are using both. They're using AI agent, they're using agents, and they're using software as a service, a delivery mode. One of the example is GitHub.
Okay.
In GitHub, if you're implementing your DevOps CI/CD, you have to actually deploy an agent on your server where you want your code to be deployed and run. And that agent will be communicating to the main GitHub server to collect metrics on how you are using that CI/CD functionalities through GitHub action. It's got the metrics and everything and push it back so they can bill you. So we have an agent-oriented architecture to build the system, and we have software as a service as a model of delivering that system and monitor the usage. So they are not mutually exclusive compared to what the CEO of Microsoft said. Another easy example to explain this is like someone claiming that because self-checkouts in shops are becoming trendy, then all the shop will close in the future. There is no direct correlation between self-checkouts and the existing of shops. The only thing that could make shops vanish is the online shopping, for example, because all of them, they are delivery modes. How do we bring the merchandise to the user? Online or in store? So those two could compete, but not the checkout. Checkout is just an internal architecture on how to make the payment and the payment of the good that's been purchased easier. So we cannot say that because we are doing self-checkout now, the shop will vanish. So this is the same context where I see the inaccuracy of that statement. But yeah, go
Sorry.
ahead.
Yeah, I wanted to circle back to talking about sort of the aftermath of this sort of world, this sort of paradigm where people, we have AI writing most of our software. And
Yes.
I was thinking about what is the impact of that on actual programming languages. It feels like when I think about it, I feel like suddenly there's very little need for a lot of languages. Like you'll probably need only few languages because again, I don't really have to learn it. If the system's gonna write it, do all that stuff, you don't need to worry about which language is, easier to learn, or you're only really looking at about maybe performance, and a lot of that will happen on lower level, not on the level where you're actually writing the sort of the syntax and the programming language. It's, for example, like Java, you've got like I think it breaks down into like C code and all of that stuff. So what do you think? What do you think about what happens to programming languages?
Yes. So once we reach the required level of maturity in this model of prompt engineering to compilation, we will actually start venturing new frontiers of learning where we start exploring how to completely bypass the programming language layer. Because if we can talk to Java, if we can talk to the model and the model gives us Java and then we compile Java in bytecodes and then from bytecode in binaries, we can also learn how to talk to the model and the model gives us straight away the binaries.
Exactly.
So that will be the latest stage of development in the application of AI in the software development lifecycle. Programming languages will be completely useless, and the only programming language that will be universal is the human language. So we'll be programming in English, in French, in Swahili, in Yoruba, in Cantonese, in Hindi, and so on. That's the future of programming. No more intermediate language to translate instruction from the human to the machines.
Very interesting. Is that, I guess, when you think about it, there's disruption sort of, when you think about the advent of the rise of the internet, it killed off newspapers, but it created websites, right? And that in turn created, so you can imagine all the people whose businesses are largely built on newspapers and passing information through paper, you know, and a lot of that was taken online, so a lot of those businesses, some of those jobs were reduced, but then it created more jobs. So you would imagine that that's what will happen with AI. So with regards to software development, what do you think will be the new type of roles? I know you said prompt engineer, but what else? I can't imagine that all you need is a prompt engineer to create a project, right? What else do you think we might need in that world?
Yeah, exactly. With uh, when AI is becoming more ubiquitous in the society, of course, some of the jobs will go away, especially the non-dynamic jobs, the jobs that cannot scale. They will obviously go away, and the dynamics one, the elastic ones, I mean, will remain. And software engineering is one of those elastic jobs because AI will just improve the efficiency of delivering software in large quantities at higher speed. So we won't experience that. But it will require adjustment in terms of skill sets. The first one I mentioned is prompt engineering, and the second most critical one is fine tuning. Because all of these large language models that are being trained using billions of dollars, they're very generic. But for you to develop an agent that will be customized to solve a specific problem, a specialized problem, you need to take those large language models and fine tune them so that they can perform the tasks in the boundaries of your own requirements at a cheaper cost.
Mm.
So fine tuning will become one of the second skills that will be very critical into that field. And another one will be maybe a kind of evolvement in the role of data scientists that will become more specialized as well based on different domains we'll be dealing with. AI agent, which is becoming the de facto architectures for software system requires a certain level of specialization. So data scientists will also be required to make some shifts. I think that's kind of specialization will be defined on how that specific industry evolved. But on the engineering side, besides the skills to build APIs, because everything will be based on APIs as usual, they need prompt engineering and fine tuning capabilities.
So think of a practical example. Yeah, let's use like the banking sector, right? Let's imagine,
Yes.
because let's say, are you saying that you'll then need specialized AI models to build banking applications, or are you saying you'll need a specialized model for a specific bank to do what that bank wants?
Yes, it should be like that. But the banking example, because we are not, because larger societies not usually does not understand the internals, the
Of
intricacies of how banking works. Let's use an example that is,
let's use e-commerce, I guess. Maybe is that better? Is that
let's use the machine translation model domain. So let's
okay?
say you are building a training system.
Okay.
So you are hired by a company to build their internal learning system.
Okay.
So a learning system could be ELMs like
Mm-hmm.
Udemy,
Yep.
LinkedIn, Academy, and
Okay.
so on.
Okay. Okay.
Yes. They want to build something like that.
Mm-hmm.
And then they say, we are living in a multicultural country
Mm-hmm.
where we need to cater for different languages.
Okay.
Like in Canada, we have two main languages. We have English and French, and let's say the extent. So we have a diverse population. We need some African languages. We need some Asian languages as well to be part of the official languages of the country. So your system should be able. So we'll be just creating one version of the content. That content will be in English, but if a French-speaking person logs in the system, everything needs to be generated on the fly for them in French so they can do the course in French. If it's in Arabic, same thing. If it's in Swahili, the same thing, and so on. So what you have to do to build this kind of systems, you have to pick up a large language model for machine translation from one language to many languages. You take that model because it's pre-trained already, which means it has the foundation for you to build your application. But there is always a specific jargon for every field. Let's say the course is a programming course. So you cannot use the general vocabulary to translate from English to French a software engineering course, for example. It will be inaccurate because
Okay.
certain
Don't
terms
have.
don't
Don't
have the same
have.
meaning.
Yeah. Okay.
Don't have the same meaning. So you need to take that model and fine tune it
Okay.
to specialize in translation from English to French, but for
Mm.
the software development content.
Oh, okay. Okay. I got it. That's interesting. That's interesting. There'll be a lot of specialization. I can
Yes.
imagine. Yes, there'll
So
end up
that
being.
applies also to banking. So in banking, maybe if you're dealing with credit card transactions, there are certain
Mhm.
features that are specific to that, and the general model cannot fix it. Then
Mhm.
we'll need someone who have a better understanding, who's very good in that field to support the fine tuning of the model to be better in doing that specific job very well. So that specific agent can be performant.
Okay. That's really interesting. I equally, I like all the things that I see right now and the capabilities of AI. I use a lot of AI for productivity, in my personal work and in all the other areas where I can, and you kind of see, when you think about it, you can just imagine all the things that you can end up doing with it, even, and as an engineering manager, I think about, sometimes I think, can AI be a manager? It's like that's I don't know the answer. I feel like, it's harder because it's not it's not just based off of, like, software development is, I ship code, the code works, I've done my job, right? It's like,
Yes.
as an EM, you're trying to manage a project. So can AI manage a project? Because it's not a, it I mean, maybe it can. I don't know if I don't know. I mean, you can probably set it up to do certain things, like if this happens, do this. If this happens, do this. But yeah, I don't know if it's. I don't know if that would feel real, or how, I don't know how that would feel to all the people in the project. So I guess my point, what I'm trying to say is, how, apart from like, even, software development isn't just about developers, right?
Yes.
There's a lot of people in the life cycle. There's managers, there's PMs. I think that's another thing. Like product managers, it's not management. I think is also something that requires a bit of not just thinking, but it requires a bit of nuance. And
Yes.
I wonder how, if that's something that AI can replicate. Um, I think it would be difficult, but I would be, I wouldn't be like, let me put it this way, I wouldn't be surprised if someone try to build something like that. But I think things like QA, I think those ones are, it's a lot easier to automate things like that in terms of like, okay, I want to, this is the desired state of this application. We already automate QA, we already automate testing, and it's not far fetched to use AI to make that even better and even faster. Or, like there's also, like I say, and even sort of design. But I think design is, you can use AI to make the designs, but it's kind of like, can AI tell you, which design is better? I don't know. Maybe. So so I mean, what do you think about all this?
Yeah, the way I think about it is, as machine learning models are becoming good at doing virtually anything that human can do faster and better, the definition of intelligence will change dramatically, because right now we are trying to measure intelligence in a more mechanical way, like how good are you in math, how good are you in algorithms and data structures, how good are you in languages, are you in art like painting, poetry, music, and so on. That's how we are trying to measure intelligence. So the machine will do that better than anyone else. So we won't be use that anymore to measure intelligence. We'll shift. We'll start using spiritual qualities to measure intelligence. How kind are you to other people? How generous are you? How considerate are you? How compassionate are you? How empathic are you? Because these are the things that machine will never do. So the higher you have compassion, the higher you have consideration for other people, and so on. That will be the new fabric for the definition of an intelligent human being. Because these spiritual qualities are the essential ingredients of emotional intelligence. And some of the roles you mentioned that involve people management, like an engineering manager. So it's not just technical; it has also a very big component of an engineer of people management. So it will require that level of emotional intelligence to qualify as an excellent engineering manager. And the machine will never do that. So I will see that shift in the future where we start valuing more emotional intelligence and spiritual qualities that can only come from the human soul and not from a machine. That will be the landmark of defining performance for any role that involves people management in any organization. That's how I see it in the future.
We can definitely end. So no matter what you do, machines, you're never taking top spot from us.
Of course.
We're here to stay. Okay. I mean, that this was a really good chat, Baron. I'm really happy to have dived into this topic with you. And again, thank you once again for coming back on the show. To all the people watching, hope you learned something. Hope you were able to change your viewpoint in some way. And enjoy the rest of your day, Baron. Besides, maybe you can tell our people, our viewers, where to find you.
I'm usually on LinkedIn.
Yeah.
So if you just search Baron Ntambwe, I'm sure till now I'm the only one that name on LinkedIn. So my profile will come up.
Awesome, awesome. Okay, cool. Thank you very much, and enjoy the rest of the day, Baron. Take care.
Thank you very much, Hugo. Have a good afternoon.
Bye.